Rates of reactions. There are many different kinds of chemical reactions. Some are endothermic, which means they absorb heat, and some are exothermic, which means they release heat. Some exothermic reactions release energy as heat, and some release energy as light. If a reaction produces light, it's called chemiluminescence. Today, we're going to be talking about the reaction between hydrogen peroxide and diphenyl oxalate. These are the chemicals that are found in glow sticks. You can often find glow sticks at raves, along with drug addicts and women with loose morals. Now, the hydrogen peroxide oxidizes the diphenyl oxalate. When it does this, the electrons are excited during the oxidation. They're excited just like drugged out women at raves. Now, both of these have set concentrations that we have determined beforehand. So the only thing that can really affect the rate of reaction is this term K. Now we call this the rate constant. If we can somehow change K, we can change the rate of reaction. Well, how do we do that? By using the Arrhenius equation. We have the rate constant K, which we are solving for, the frequency factor, the activation energy, which is set at 50,000 joules per mole, and the gas constant, which is 8.314 joules per mole Kelvin. The three temperatures we will be using are here. You can see them up here. When we do the calculation, we attempt to show that by changing the temperature, T, we can change K, the rate of reaction.
Alright, so we are going to use three different temperatures. We're going to use this Arrhenius equation to show you how K is actually changed. So,
Changed like the drugs at a rave.
At a rave. So, the first temperature we're actually going to use is T is going to be room temp, which comes out to be 294 K. Okay, so K equals, we can actually assume A is 1 because even if this was a different number, all it would do is scale this number. So we're going to assume A is 1 and just use E. Activation energy is 50,000 joules per mole over R 8.314 joules per mole Kelvin, and then times temperature is 294. Lucky for you, you actually don't have to do this calculation because I have already arranged and did it myself.
That's good, because people at raves don't like doing math.
They don't. So, this comes out to be 1.31 times 10 to the negative 9. Alright, so that's the first temperature. Second temperature, boiling water. Comes out to be 373 Kelvin. That answer is 9.96 times 10 to the negative 8. Last temperature we're going to do is cold water. That temperature is going to be 273 Kelvin. I'm going to plug that in to this equation. Kelvin. That's going to equal 2.71 times 10 to the negative 10. As you can see, these values, K at boiling temperature is a lot bigger than it is at room temperature. Room temperature is bigger than at cold water. So, the higher the temperature, the larger the K. The larger the K, the higher the rate.
Now, if the rate of reaction is higher, that means that more electrons will be excited. Again, like the women at raves. If more electrons are excited, then more light is emitted. And we attempt to show you this in this small chemical reaction where we will show you light sticks at 3 different temperatures. So as you can see, the glow stick in the hot temperature is glowing brighter than at the room temperature. And you'll notice the glow stick in the cold water is the least bright. This serves to prove that if you change the rate constant by changing the temperature, you can change the rate of reaction. Thanks.